Hi everyone, today we're going to study circular functions. Let us begin with unit circle. This is a picture of a unit circle where the central angle, it is here, is denoted by letter T. And this T is measured in radians. Let us define unit circle. A unit circle has a center at 0, 0. This is the origin. And radius 1. This is the radius and the length is 1. In a unit circle, the length of the intercepted arc is equal to the radian measure of the central angle T. This is the intercepted arc, the length S, and this is the angle T measured in radian. They are equal in a unit circle. Considering now this arc S, let xy, this is the ordered pair, be the endpoint on the unit circle of an arc of arc length S. So from here to here, this is the arc S. The x and y coordinates of this point can be described as functions of the angle. For the functions of the angle, it will be described in the succeeding slides. Let's go now to sine and cosine functions. T here is the angle. If T is a real number and a point xy on the unit circle corresponds to an angle of T, then the cosine of T equals x and sine T equals y. If we're going to write the ordered pair xy, this is equal to cosine T, that is for the x, comma, sine T, and this is for the y. Let us go now to reference angles. An angle's reference angle is the acute angle T formed by the terminal side of the angle T and the horizontal axis. This is the x-axis. A reference angle is always an angle between 0 degree and 90 degrees, or 0 and pi over 2 radians. This is the general picture of an angle in first quadrant. In here, the reference angle is the same with the given angle. So we see here, reference of T equals T. In the next figure, it gives us the general picture of an angle in the second quadrant. But you see, as per the definition, a reference angle is formed by the terminal side of the angle T and the horizontal axis. So this is the terminal side, and this angle here is the reference angle of this given angle in second quadrant. So we can compute for the reference angle by this formula. Reference of T equals pi minus T if the angle is given in radian, or 180 degrees minus T if the angle is given in degrees. In the next figure, this is the general picture of an angle in the third quadrant. This is the third quadrant. This is the terminal side of the angle. So from here, it goes here and stop on the terminal side. Again, the reference angle is the acute angle formed by the terminal side of the angle T and the horizontal axis. So this angle here is the angle formed by the terminal side with the horizontal axis. So this is our reference angle. The formula is here. The reference of T is equal to T minus pi if the angle is given in radian, or the formula is T minus 180 degrees if the angle is given in degrees. The last figure here is the picture of an angle in quadrant 4. So from here, it goes and stops on the terminal side. This is now our angle. And this angle here is the acute angle formed by the terminal side with the horizontal axis. So this is our reference angle. And the formula is here. Reference of T equals 2 pi minus T if the angle is given in radian, or this is equal to 360 degrees minus T if the angle is given in degrees. Let us have an example. The first example is 30 degrees. Since this is an acute angle, it is found in first quadrant. And the reference angle of 30 degrees is itself. So the reference of 30 degrees is 30 degrees. Another example is 150 degrees. This angle is found in the second quadrant. To find the reference angle, we will get the difference. So 180 degrees minus T, the given angle, which is 150 degrees. This is equal to 30 degrees. It means to say the reference angle of 150 degrees is 30 degrees. Another example is 210 degrees. We know that this angle is found in the third quadrant. For us to get the reference angle, we will use the formula T minus 180 degrees. It means 210 degrees minus 180 degrees equals 30 degrees. It means to say the reference angle of 210 degrees is 30 degrees. Last example is 330 degrees. We know that this angle is found in the fourth quadrant. And we can get the reference angle of this by using the formula 360 degrees minus T. And this T is the given angle 330 degrees. So 360 degrees minus 330 degrees equals 30 degrees. Again, the reference angle of 330 degrees is 30 degrees. Let's go now to signs of trigonometric functions in quadrants. First, let us have a short review. This is our x-axis. This is our y-axis. The two lines divides the plane into 4 quadrants. This portion is the first quadrant. To the left is the second quadrant. Down here is the third quadrant. And on the right of the third is the fourth quadrant. Next, let us write the 6 trigo functions or ratios, namely sine, cosine, tangent, cosecant, secant, cotangent. We know the relationship of sine and cosecant. They are reciprocal. The same way of cosine and secant, they are reciprocal. Also, tangent and cotangent are reciprocal. Let us now write the signs of trigo functions in the quadrants. The first is all functions are positive in quadrant 1. Next, sine function is positive in the upper quadrants, and the upper quadrants are the first and the second quadrants. Third, cosine function is positive in the right quadrants. The right quadrants are the first and the fourth quadrants. Last, tangent function is positive in the alternate quadrants. Alternate quadrants are the first and the third quadrants. We can easily memorize these principles by remembering this simple word, sukrita. The SU is for the idea of sine function, S is for the sine, and the U is for upper quadrants. The U is the first letter of the word upper. Next is the CRI. The C is for the cosine, and the RI are the first two letters of the word right, that denotes right quadrants. And last is the Ta. The capital T represents the tangent, and the A is the first letter of the word alternate. Sukrita. Remember the word. I hope you learned something from this video. See you again next time.